Hello everyone, this is part B of our project, and our business name is Smart Mosquito Trap. Our targeted customers are households and families, hospitals and clinics, hostels or hotels, lodges, resorts, school dormitories, and government as well as NGOs. Then our problem space and purpose. First of all, the core problem is that malaria remains a major global health challenge, especially in Africa. We see that many people, especially young children and older people, suffer from malaria and die because of it. So who experiences it most? Households in malaria endemic areas, especially rural areas like in villages where there are a lot of trees, there are a lot of stagnant water. Many people suffer from malaria. Hospitals, people are still sick. Then hotels, resorts, and schools all are exposed to mosquito infections. And also government is affected because it spends heavily on mosquito control and treatment. Then why AI is essential here? AI enables real-time mosquito detection, classification, and behavior analysis, which simple identification of real mosquito cannot achieve. You see that AI is able to detect a mosquito and classify it that it's a malaria-carrying mosquito, which a normal human being with their eyes cannot. Then AI reduces manual inspection costs and increases accuracy in identifying disease-carrying species. Here, if we deploy AI in controlling malaria vector, we save a lot of costs, such as inspection costs. Then the measurable impact, first of all, in health, this AI has led to reduction in mosquito-borne diseases transmission in deployment areas. In areas where we have deployed a model, the reduction in mosquito-borne diseases has really reduced. Then in the economic impact is that the government is spending low investments or low income on eradicating malaria. Then social impact, it has improved the quality of people and productivity due to fewer illnesses. Then users and stakeholders and ecosystem actors. First of all, the primary users or the end users are households and families, hostels, schools, institutions, hospitals, and health centers. These are people who are going to use or who use our deployed mosquito trap. Smart mosquito trap. Then the secondary stakeholders, we have NGOs and public health organizations, regulatory bodies such as UNBS and NEMA, investors and manufacturers, as well as researchers and universities. Then the ecosystem role, data servers, ecosystem roles, these are people within the ecosystem, such as data suppliers, such as the researchers of Oxford University that provided us with the Harvard degree that we used in deploying our model, algorithm designers, there are also stakeholders, then API consumers, health agencies, and mobile apps accessing mosquito trade data. Then in our continuation, we have governance entities. We have Ministry of ICT and Innovation here in Uganda and system audit teams. And regulatory compliances, we have National Environment Management Authority, which is NEMA, and Uganda Bureau of Standards. They are all stakeholders. Then data sources, one of our data sources, data types are data types. The system relies on multiple forms of data to enable intelligent mosquito detection and monitoring. One of which is audio data, mosquito wing beat frequencies captured by embedded sensors. We used microphones, then tabular data such as mean, median, and species counts and location-based logs. Then the sources of our data, first of all, proprietary allocations, data gathered. This is data gathered by deploying smart mosquito traps in various regions. Then community contributions that are shared by households, health cares, and field researchers, as well as mosquito open data sets. This was also a supplementary mosquito sound data sets from researchers among DB data sets from Oxford University. Then we had our processing pipeline collection. We use sensors and microphones to capture raw mosquito activity data, then cleaning, noise reduction, and removal of irrelevant background sounds. Validation, We had cross-check by automated AI accuracy checks. Then storage, we secured cloud database with backups and encryption for long-term data management. Then we had the ethical and legal frameworks. Here, how was our project compliant? It had first of all it adheres to the Uganda Data Protection and Privacy Act of 2019. Data governance regular audits to ensure fairness, transparency, and responsible AI use. Then the value mechanism, the social value. First of all, this enables the smart mosquito trap enables real-time mosquito population tracking and early breakout prediction, reducing malaria transmission. First of all, the trap is very effective in that it enables real-time mosquito population tracking. Then commercial value data-driven insights can be monitored through partnerships with health agencies. The scientific value is that this project contributes to entomological datasets for future mosquito that the entomologists use our data for future mosquito control and research. Then the solution, an AI system description. First of all, our AI is acoustic event detection. It uses acoustic sound or mid frequency to detect the mosquito. Then, at species classification, after identifying it classifies the mosquito using deep learning, CNN, and graph neural networks. First of all, our inputs were raw data from datasets, and then the intermediate inputs were acoustic features such as low frequency, substroke coefficients derived from the raw data. Since some models could not use direct raw data, we first of all extracted features from that raw data. The outputs were detection of malaria vector and classification of mosquitoes. We were able to detect first of all classify which mosquito is this one, and then determine the one that we needed, the malaria vector. The core algorithm was feature extraction to classification. The algorithm we used a lot of the pipeline was low or about stage process to first of all extract features and then classify them. Then how the AI generate the decisions, how this AI that we are using, the smart mosquito trap, generates valuable entomological and public health insights by aggregating and conceptualizing the individual classification decisions. How the AI integrates with user workflows. It is designed, first of all, AI is designed to integrate seamlessly with public health and vector control workflows through Internet of Things. Then our key metrics and evaluation. We used a lot of key metrics, and this is how we determined how successful our project was. First of all, we've actually seen a higher percentage. When we got a higher percentage, maybe 90% or 91%, that was an indication of success. F1 score is very high score, closer to 1.0, was an indication of success. Then the throughput, load time, uptime, and all this, the ethical success, how we knew that our company was successful ethically. First of all, fairness, how we indicated that it was successful was outcomes or error rates were statistically similar across groups. Here, the bias mitigation, a significant reduction in pre-identified bias metrics post-mitigation. Then user-centric metrics or driving commercial success. The adoption rate, first of all, the metric we used was adoption rate, high percentage of target users utilizing the product. Since we saw that the adoption rate, since we saw that a lot of or a high percentage of targeted users, as we saw earlier, are utilizing the product, then we knew that the product was indeed a success. Then user satisfaction, a high average score like that. Then the business and financial metrics. First of all, the lifetime value, which is a high value, the churn rate, which was a low rate, revenue growth, which was a high percentage growth, all of that indicated the success of our product. Then the unfair advantage and differentiation was that the proprietary acoustic datasets, our product uses labeled with mid sounds optimized for diverse real world noise. Like our product uses real world noise. If it's a background noise, a fan noise, rain, or voices of people So that makes it a fair advantage. Then the field validation loop. Then the field validation loop is that low confidence classification are sent to expert. We send the results we get from the deployed areas to experts to review them also and also manually correct the labels that were first of all classified by the model in the project. So the highly effective small footprint of micro SCD net. Remember, micro SCD net was the model we deployed. Enables low cost and low power edge computing for rapid scalable deployment. Then the channels and distribution. First of all, the channels we use webinars and conferences where we demonstrate the real time how our product works, then engaging developers and data scientists within partner organization. And one of the delivery channels are promotions, demonstrations, and tech expos. We go to different media coverages. We can use our own media, social handles, and free API integration for education platforms. Those are all channels of distributing our product to the targeted customers. Then revenue streams. Selling, how we get revenue from our products is selling anonymized, aggregated historical links activity as well as trade data. We sell this data to maybe NEMA, to government agencies, to NGOs, and we acquire revenue. Then offering expert services for deployment optimization, target intervention strategies. We offer expert services on how to deploy our models, on how to use our products. Through that, we can charge people a certain fee. Then a monthly or annual fee charged by government. We charge government a monthly or an annual fee for the use of our products. Then key resources, one of the resources that we use, first of all, the human resource we used, machine learning engineers and data scientists. This were needed to develop, optimize and maintain the micro SCD net and FNN as well as GAT models. Then we needed user interface designers to create a dashboard. Then the data resources, we needed a legal or IP protection unit. Then the financial, we got grants and seedings from government and different NGOs or agencies that could help us to produce our products, and even through consultancy income and organizations like institutional collaborations, all that with some of our resources, as well as Google Scholar researchers who provided us with papers that help us to achieve this project. Then the key activities. You have the model life cycle. The model life cycle is that every month we train using new data set from deployed areas. We use that data again to retrain our models and our product to see whether it's working correctly in such environments. Which operationally, we continuously track the performance metrics of the model against new incoming data to detect drops in accuracy. We first of all continuously track the performance, so as the performance metrics, so that we see whether the model is still working accurately even after a certain period of time. Product deployment activities, designing the intuitive web dashboard for field technicians. Key activities that we redesign or we design the interface again to make it more attractive. Then customer focused activities, facilitating knowledge. Yeah, then key partners, we had data partners, we had local ministry, cloud servers, and telecommunication companies, research institutes from Google Scholars, all our key partners. Then cost structure, data structures, first of all, data costs like 10 million every year for the good data sets and local collection. The computing plan, hybrid cloud plan, with that, it's 7 million per half a year. Then marketing and sponsorship of AI Week, Uganda, and other tech expos cost us like 10 million annually. Governance, ethics, and compliance components of AI solution. The system adheres to principles requiring prior consent for data collection and ensures the data is collected fairly and lawfully and observes strict security safeguards. Then the scalability and sustainability of our product is that microservices and containerization like Docker for the cloud infrastructure, continuous learning, automated model retraining after a half a year with new audio sounds, backup models on the centralized cloud to ensure continuity during outages. Yes. Then the intellectual property and innovation was that the unique architecture and process flow of the micro acoustic deep like the micro SEG net is patentable, then the massive proprietary acoustic data of Mosquito liquid sound is also copyrightable. This is the team contributions. Thank you everyone for listening to me. For any question, you can call me on that number or any of my partner.